Hi, welcome to Final Pie Videos. This is DC here. So this video is titled as using the Icode SLI tag. But if you have been following all my previous videos, I have already used this Icode SLI tag in my previous videos. Now from this point onwards, so I would like to make videos for specific tags. Say for example, this is going to be like Icode SLI, next will be Icode SLIX or SLIX2. It could be the TI tags, or it could be the SLIX tag. So we have already seen most of the working of Icode SLI tag in my previous videos. So in order to make this as a complete series, I've just introduced this video. And however, this video is going to be a bit of a theoretical, but to keep the video interesting, at the end of this video I'm going to show you a few features of Icode SLI tag. These are some of the features I've extracted from the datasheet of Icode SLI. So this is supposed to be the very first generation of a smart label using the ISO 15693 standard, and this tag supports DSFID, AFI, EAS and locking. You might find DSFID, AFI and locking in most tags. However, you may not find this EAS in every tags. So it has got 32 blocks and each block has got 4 bytes. Out of this 32, 28 blocks are used to store the user data. So the remaining 4 bytes are used to store the is called a configuration data. Somewhere in the tag it has to store the UID, the log bytes, the DSFID, AFI, so on and so forth. So these 4 blocks are reserved, and you cannot directly access these 4 blocks. So this has got a lock bit. Each of these 28 blocks can be locked, and when the lock is set to 1, it cannot be reset. It also supports the locking for EAS. Now you may be probably, if you're depending on what you want to do, you might have to look into the features of the tag you're going to use in your project. So this one has got EAS. In addition to that, it also has got a way to lock the EAS. So one of the interesting feature of this ISO 15693 standard tag is, on error, it could be you're sending the wrong command, or it could be a wrong number of parameter. The tag will remain silent, and when it's silent, it doesn't return any response, and the tag will be ready to process the next valid command. If you compare this with other like a MeFair or a NTag, NFC tags, so where you can see that tag will automatically go back to the ideal state, and where you have to start all the activation process all over again. So these are all the commands supported by the Icode SLI tag, and on the left side you can see there are the 2 commands. If you see this mandatory and the optional, now this refers to what you see in the standard document, not a tag specific document. If you see this ISO 15693 part 3 documentation, it says the mandatory commands are inventory and stay quiet, and all other commands are optional. So every tag must support the inventory and the stay quiet, and tag doesn't have to support any of these tags. Again, without these commands, so don't know what the tag can do. So I've not come across any tag where you don't have a read or a write functionality. So I'm going to go through this quickly. Most of these commands we've already seen in my previous videos. The stay quiet, it's something we have not seen before. That's what I'm going to cover in this video. Inventory, this is the standard way of activating the tag. So you got the read single block command. This option plays a very important a role in this ISO 1569 standard. Now you have to get yourself comfortable with this concept of option. Option is like sending additional parameter to the command. Take for example how the read single block command works with the option bit. Remember, option is part of the request flag where it can be either set to 0 or set to 1. Now when you send a read single command with option 0, you get 4 bytes of data. If you send the same read single block with the option flag set to 1, you will get 5 bytes of data. So you will get the 4 bytes of data plus the log byte. So looks like this is like additional information you're passing to the tag. So the next thing is the write single block. You have to be very careful when you look at these commands in the datasheet. Now I'm sure most datasheet will tell you whether the command works with option 0 or option 0 or 1. Now in this SLI datasheet, so it says the write single block works only with option set to 0. It doesn't work when option is set to 1. Now I'm going to show you in my future videos about the Texas Instruments tag where the write only works with option 1. It doesn't work with option 0. So this option thing is it's a very important concept, so that you have to understand it well. Similarly, the lock block, where you can lock a block, it works only with option 0. In Texas Instrument tags, it works only with option 1. Read multiple block works with both option 0 option 1. Option 0 will give you the data. With option 1 you will get the data as well as the log byte of each block. And the write and lock AFI also works only with option 0, and the write and log DSFI works with, I think it's option 0, sorry, this option 0. And because this is a first generation tag, most of these commands, they all work with only option 0. So likewise, the get information and the get multiple security block, these don't depend on the options. I'm not sure what happens if you send the option flag to 1. Now get system information, this is the command we use to get all the memory capacity and the block size and the UID of the tag. Plus get multiple block security, we have seen this thing, and this will return you only the log bytes. And the select and reset to ready, these are part of the activation process. The select, reset to ready, and the stay quiet, these are part of the state diagram. If you look at the documentation, I'm going to show you how this stay quiet, select, and reset to ready works in this video. Next I'm going to speak about the custom commands. Custom commands are not part of the standard document. So a manufacturer can introduce any number of commands. So in every custom command you have to send the manufacturer code, and the manufacturer code you'll come to know from the tag itself. We already know that code 04 stands for NXP and 01 stands for probably TI and so on. So the main advantage is to utilize some additional features of the chip or the tag. Say for example, there could be a custom commands to authenticate the password. There could be some custom commands to encrypt and decrypt using MAC and AES. So this we already know, the manufacturer code for NXP 04. Now in this SLI tag there is a command called inventory read and the fast inventory read. Now what inventory read does is it works as a normal inventory command. In addition to that, it can also return some data. So assume that you want to read, say, 10 blocks of data from a tag. Now normally what we do is, it is done in 2 steps. The first step, you send the inventory command, and the second step, you send the read command. Now if you think, these two, read is always done in your software system, in that case you can use this inventory read command. What it does is, it does both this operation but using only one single command, so which is a nice to have feature. So if you have got a very busy system, then probably reading the tag will be much quicker with this command. And this also works with say option 0 or a 1. Now again, the option 0 or 1 is not the same as option 0 1 you saw with the read single block command. Now I'm going to show this at the end of this video, how this inventory read and with option 0 and 1 works. There is a variant of this inventory read command called fast inventory read command. Now the difference between these two is just the rate at which the data is sent to the reader. So if we use the fast inventory read command, the tag will use a higher speed, say for example 53 kbps speed rather than the standard 26 kbps. Now I'm going to show this as well. We have just touched upon this command in my previous videos, but I'm going to show you this in detail in this video. Some of the custom commands which you see in SLI datasheet is setting the EAS bit. The EAS is not part of the standard, so it's a manufacturer specific feature. Now obviously working with EAS will be part of the custom command. You can set the EAS, you can reset the EAS, you can log the EAS. You can also command to see whether there is the EAS has been triggered. So I'm not very not seen this how the EAS thing works, but in theory, from the developer's point of view, so there is a command called EAS Alarm. Okay, if the EAS enabled, then this command is going to return you 32 bytes. Now keep in mind, EAS can be enabled or disabled. Now but when it is locked, you cannot change the status of this enabled and disabled. So most often it's very obvious that you set the EAS, then after that you lock it. But for all the new tags, it's not sure, the document says not sure whether the EAS is set or reset. So there are some recommendation in the documentation that says for every new tag you have to, if you don't want to work with the EAS, then we better say reset it, then you can lock. It's not reset, probably it's enabled, sorry. It's to enable the EAS or to disable the EAS and lock it. We're going to see this in a later part of the video. So for any developer, you cannot ignore the errors. Now you have to understand how to handle the errors when you work with ISO 15693 tags. And as we know that most of the tags, they ignore the error and they're waiting for the valid command. So this is a nice feature to have, if you ask me. So but the way the tag handles the error depends whether the tag is been used in address mode or a non-address mode. Now we already seen what is address mode. In address mode, the command carries the UID of the tag. So the command is targeted to a very specific tag. That's address mode. In a non-address mode, the command does not carry any address information. Every tag in the field will respond to the command. This cannot happen because there will be a collision, but you can also work with the single tag in a non-address mode. So in a non-address mode, you send a command without any specific UID, and the only tag in the field will reply or respond to that command. So these are some of the highlights of the address mode, non-address mode. In a non-address mode, the tag ignores the command. It just stays quiet. Whereas in the address mode, now this is all about how the error is handled. In the address mode, the tag returns the error code 0f, and the address mode here means whenever the address flag is set to 1 and the UID is present in the command. Okay, that's what the address mode is. So in address mode, you set the address flag to 1 and the UID is present in the command, and obviously the tag that matches this UID will respond. And also you can also use a method called the select mode. So here this is also a kind of a address mode. So the only difference here is you do not send the UID of the tag in the command. I'm going to probably show this thing in my later part of the video. So if you got, say for example, these are the 3 tags in the field, and this is your the reader writer. Now out of these 3, only one of the tag can be set to the selected mode, or you can select just one tag. Now all the commands coming here which says this command will go to the selected tag will obviously reach only one single tag. Now in both the scenarios, in the addressed as well as select mode scenario, the return code will be set to F. So we are going to see this about the operation modes in this probably now I might have to do one more video to explain this slowly and in detail. Now there are 3 modes of addressing a tag. It is the address mode, and it's a selected mode, and non-address mode. So for the developers, you have to get yourself comfortable with these 3 modes. So I've already seen this before. In the address mode, the address flag is 1 and the command carries the UID, and the tag matching UID will respond. In select mode, once the tag is selected, the flag called select flag is set to 1, and only one tag can be selected in the selected state. The tag in selected state will respond. So in the non-address mode, all tag will respond to a command. Obviously this can never ever happen because there is a collision. So the collision is possible. Now this works only when there's only one tag. Next I'm going to show you how to use the custom commands of Icode SLI tag. The version of the software I'm using is 2.1, and a lot of new things have gone into the software which I'm yet to make the videos. Now some of the new tags added since the last version is you can use UID changeable tags, and you can also use the MiFi Classic EV1 to personalize the tag. Now you can see I've connected my PN5180 board with Arduino, and I'm going to choose the ISO 15693. So as we did before, the first thing is we turn on the RF, you click on activate, to activate I need to place a tag. So this is kind of a brand new tag. This is still in SLI. I'm going to activate and go to the system tab and click on the get information, and you can hit this read entire tag. You can see this is a brand new tag, and I'm going to show everything you got in the Icode SLI tab. Now this tab is very specific to the SLI tag. All the commands you see here works only with the SLI, and also the later versions of Icode like SLIX, SLIX2 and SLIS, all the future generations of SLI tags also have these features. Now first I'm going to say, if you hit this alarm, if you get this error message, so this means the EAS is not enabled in this tag. Now I'm going to show you a couple of old tags. So whenever you replace a tag, you have to again start from the activate. You got a new ID and go to the system and click on this alarm. You can see this is the bit patterns you get from the tag, and in this version, in the SLI version, you cannot modify this bit pattern. In the later versions, say for example, there is a version of SLI called SLIX2, which I'll be doing videos, maybe in the future. Now SLIX2 has a feature where you can also modify the EAS. This is called as a EAS ID, but in this version SLI you cannot modify. This is permanently hard coded into the chip itself. Now this is already enabled. Now I'm going to try to disable this thing. So you can see that the reset EAS failed because the EAS has been already locked. So usually what you do is you either set or reset, or you enable or disable the EAS, then you can lock it. So I've got one more tag here, which is again not a new one. So we'll see what that tag has got. Activate and get the system information. Go here and click on alarm. You got the alarm. If you see the commands that are going here, this is, if you ignore this A1, everything after that is this custom code. So this is 02, A5 and 04. So let me open the documentation and just go through a couple of the command structure with the documentation, and then you'll understand what's actually is going on. Now this is the command structure from the document. So we are not using the address mode. So the grayed out here, it's an optional. So you need to pass the 8 bytes UID only if the flag says it's in address mode. Probably I'm going to go demonstrate that as well. So if you ignore this bit, what you are sending is the 1 byte of flag, the 1 byte of EAS command, that is A5, and the 1 byte of manufacturer code. So only 3 bytes are required to run this alarm. So if you go back to the software, and you can see here the 02 is the flag which come from, if you go to operations, which come from the flag settings here, and 0A5 is the command code for alarm EAS, and 04 is the manufacturer code. So what you get in turn is the flags. This is the error flag, which is 0, and the remaining 32 bytes you get here. And these 32 bytes, if you look at this 2F and see compare the bit pattern, so this is what it is. So it's all it's shown in the reverse bits. These tags are already locked, so I'm going to use a new tag to demonstrate how to set, reset, lock the EAS field. Okay, I'm going to reactivate the tag again. Start with the new screen. Now I got it. Now you don't have to do this RF on and off because it's already on. Go to this system, get the data. We'll not be interested in the data part, so we'll go to this Icode SLI tab. Now if you hit alarm, now it's not set. So first thing you do is assume that you want to set the alarm, set the EAS, and you want to lock it forever. Now before that I'm going to show you set, reset, and later on the lock. So when you hit the set command, if you hit the set, now you got a nice message that says set EAS is okay. And we look at the command structure here. This is the flag, this is the set EAS command, and 0 for the manufacturer, and you got a clean error code as 00. Now we know the EAS is set. If you now hit the alarm, you should get this. You should see the bit pattern, and this bit pattern, I'm not sure. I think this is the same. Probably now I'm not compared with the. I think this is the same for every tags. Okay, so it's set, and you can also reset it. Assume that you don't want the EAS feature, you can disable. If you see the command structure, it is the flag, A3, and the manufacturer code. This is the custom command, and if you try to get the alarm now, you get error message. So now you know that the enable and disable both are working. Now you can go and just lock it. If you lock now, remember lock is always it's a one-way operation. You cannot undo the lock. Now if I hit a lock now, I'm going to have a tag, this tag, without EAS feature enabled. So I can do that. So I got so many tags, with the lock enabled. Probably I'm going to show that now. Now we have decided not to have a EAS feature on this tag. I'm going to lock it. Now there's a small warning here. It says it's locking forever. Hit yes. Now it says a new it's a success message. If you go to the command, it's 02 A4 and 04. If you see the documentation here, so if you look at the lock, so you got a set EAS command. Again, it's a flag, set EAS, and this. Now the lock EAS, you can see here the flags. The lock EAS is A4, the manufacturer code. Now I thought I'll have a separate video on how to understanding stay quiet, reset to ready, and select. Probably I think I've mentioned something about in my previous video about the address mode as well. Now what I'm going to do is I'm going to use the address mode this time. So I'm going to open, activate the same tag we just used. Now get the information. Now this time if you hit alarm, no, nothing happens because you get error message because we are locked. If you try to enable now, let's see what's going to happen. You get error message. Now in fact this is something I mentioned in the slide. So if we send a command, and if the tag is not in address mode, the tag stays quiet. You do not get any response here. Let's try the same thing in the address mode. Probably I'll take a different one, the one that has got EAS. Activate, get the information. Here, before I hit this alarm button, or send the alarm command, I'm going to tick this address mode. Now if you get rid of these commands and say alarm, if you look at the command structure, now here everything is the same. You got this flags, you got this the command code plus the manufacturer code, followed by the UID, and UID it's in the reverse order. You have to send the UID in the same order you got when you hit this get system information. Now this is what the address mode is. I'm not sure why you're getting this twice. Let's check. If you hit alarm, yeah, so there is probably a small bug here, so you're getting twice. Okay, so we understood address command. Now if you try to, we are still in the address mode. If I go and hit the reset, you got error message, and if you look at that, this is exactly what the documentation mentioned, and we discussed this in my earlier videos, earlier part of this video. In the address mode, for any error message, you will get the error code 0F, and the first byte 01, a 1 indicates an error followed by the error code. So we just saw how this error. It's very common most often that the developers forget to handle these type of errors. So the next command I'm going to explain is how the inventory read command works. This is a custom command, so this command must carry the manufacturer code. Looks like this is the longest command in the documentation, and this command does two things. It does the inventory, plus it also does the reading. So the first part of this command is something you will see in the inventory command, and the remaining part, the next part of the command, looks like the read multiple blocks command. So you have to use this command with inventory flag set to 1, and this command you should also pass whether to use a slot 1 or slot 16. So since we're working with a single card here, so I'll be using only slot 1, but slot 16 command you have to understand if you want to know more about how the entire inventory anti-collision thing works. So let's see how this command works. I'm going to use activate. Sorry, you have to see set this RF on, activate, and get the system information. Now in this software I have not used the data return from inventory read command, so it's just there so that you understand how the command works. So if you try to click on here, there is some information here. It says inventory flag must be set to 1 and slot 1 flag should be set to 1. So here inventory I'm going to set it to 1, and actually it's the number of slot, it's not slot 1, so set this to 1. So let's understand the simplest use of this command structure. So I'm not going to use the mask length, I'm not going to use this mask at all. I'm just going to use a simple inventory command, and I'm also going to say that I want to read starting from block 0. I want to read 5 blocks. However, you get 6 blocks here. That's what document says. So when you hit send, the inventory read is okay. If you look at the command structure, you have the flags and you have the inventory read command. It's A0. You have the manufacturer code, and you have the mask length, which is we have set to 0, the mask length, because if you look at the command structure, the mask length is mandatory. So only when the mask length is not equal to 0, you'll have a value for the mask value, which is again can go anywhere from 1 bit to say 64 bit. Everything that is not grade, they're all mandatory. So again followed by the starting block and the block number. So you got some series of zeros. Maybe this will not be a good tag to learn, because we just don't know whether it is the correct value, or I know it's a correct value, but just if you want to show this to others, it's better we have some data here. I'm going to use a different tag which has got little data. Activate, go to get. I'm going to no, get tag failed, don't know why. Okay, so what I'm going to do is I'm going to restart. So RF on, activate, get, and give read. Now here you got the data in front of you. I'm going to make small changes here. Say write. Looks everything is failing here, don't know why. Probably it's locked, so I'm going to do get multiple block security. So we are trying to modify a block that's been set as locked. Just go with here. So I'm going to make future. Okay, you got some different data here. Now let's try this inventory read command. I'm going to set the mask length 0. I'm going to read starting from the block number, say 10, and I want to read 5 blocks, so you get 6 blocks. So you get from here you get 5 blocks. So go here, set to inventory and set the slot to 1 and get rid of all these locks. Hit send. Now you got a success command here. You can see here. So we got the data from the block 10. You got the block 10. In addition to that, you get 5 blocks. So in total, you get from block 10 to block 15. Total, you get 6 blocks. So keep in mind, the number you mentioned here, you'll always get one more than that. So that's the simplest use of inventory read. Now try the other one. I'm going to, this is part of the inventory, and I'm not going to speak anything on that because that's a different concept altogether. I'm going to match the last 8 bits of the UID. So it's C9, and okay, not that. There's something else I forgot to mention about this command. The option flag is also used in this command. When the option flag is set to 1, so you get the remaining bytes or bits of the UID which is not part of the inventory. Now again, what I mentioned just now, so probably now you may not be knowing that at all. So you have to understand the inventory, the whole concept, which I covered in my older videos. Now what I'm going to do is, this time I'm going to set this option flag to 1. The same command, I'm not going to use this, and let this be 0 as well. Now let's see what happens with the same command. So send. Now here, in addition to the data, we also got the UID of the tag, not the entire UID. It depends on the mask length. Now I can change this mask length to 8, and I can also match this mask value to the lower byte C9, and if I hit send now, you will get, if compare with this, the one we just ran now, the difference here is it returns all the 7 bytes of the UID, okay, which is not present in the mask value. So we have passed this C9 as the part of the command, so you will get everything other than C9. Now you can see here it starts from 80 and goes up to E0, whereas in the previous command start from C9 and goes up to E0. Now that's how this fast read works, inventory read works. If you want to make it as a fast read, the only difference is, I'm going to go back to set to 0, put a tick on that. At the same time, here what you have to do is, let's give it a try. Okay, if it says send, you got an error here. It is because of this the configuration. Now this is what the configuration is loaded when we ran all the previous command. You have to change this and set that the receiver can use a high data rate. Load this configuration, and now if I run send, so we got the same data, but again, this is something which I can't test it. So the tag has responded with using a higher data rate. Alright, so I think that covers the Icode SLI. And just to summarize, Icode SLI is the very first generation tag, and it is, it's a good starting point because the tag is simple. In my next videos, I'm going to cover the Icode SLIX. This is the next generation, and here you got everything that SLI supports, plus it has got the password protection. After that, I'm going to go to SLIX 2. Again, this has got everything that's present in SLIX and plus additional stuff. Here, this is the tag where you can change the EAS UID It has got so many interesting features. It has got a self-destruction feature, and also I've recently acquired, bought few tags. That's SLI-S. I'm still waiting for to receive these tags. I'm still not sure how this is different, but once I get the tag, I'm also going to cover about SLI-. Okay, thanks for watching.